Okay. Thank you very much. Shall I try to change it, or shall we live with it?
It's okay. I was just going to let you know, if you change the resolution, it'll get rid of that script. It'll all boil up.
Can we live with it?
It's good. It's good.
Okay. Okay, well, thank you very much, and thank you for the opportunity to be here. It's been a really, really fun 2 days, and getting a chance to talk with students and faculty and really exploring what you have going on here, and it's a really nice thing you have going, and particularly the connection between science and policy that you all are striving so hard to achieve here, and that's what I want to talk about today. One aspect of that being carbon emissions from tropical deforestation, and that's a science issue which has been with us for a couple of decades now, and is now at the pretty high on the policy agenda, and will be a major topic for discussion at the Conference of Parties meeting, which begins next week in Bali. So it is exciting to have worked on a topic for a long time and then have it be the focus of policy discussion. It's also a little bit humbling and scary, I should say, because it really ratchets up the need to be certain about our science and be clear about our science and to not be misleading. So I wanted to talk about what we know about carbon emissions from tropical deforestation and how that intersects with the policy discussions that are underway now. So there's a number of collaborators trying to get at this issue, both from the atmospheric side, which is where Prasad comes in, and the bottom-up side from remote sensing and field work. So it takes a large number of people to be able to bring their expertise together to look at this issue from many angles. But before we get into the details of carbon emissions from deforestation and how we estimate that, I wanted to step back a little bit and think about the landscape in a broader sense and even historical sense. That if we think about how people transform the landscape with the process of development, you might say, we can think about various stages, and not that every place goes through these stages in any particular way, or some places may stay in one particular stage for a very long time, or double back and get cleared and regrow and cleared again. But in general, I find it simplifying but useful to think about these kinds of transitions that landscapes go through, from wild lands to clearing, frontier clearings, to a kind of subsistence, small-scale type agriculture, and then into an intensive agriculture stage, which is the kind of landscape that characterizes where we live. And really, that kind of transformation of the landscape reflects the other major transformations that societies go through in the process of development, whether it's demographics, from high fertility rates to low fertility rates, or diets from starch-based to meat-based, or health transitions from infectious disease to chronic disease, or energy transitions, climbing up an energy ladder from traditional biofuels to fossil fuels. So the landscape reflects all of these transitions that societies go through in the process of development, whether it's what we went through in this country or in Europe centuries ago, or whether it's currently going through these transitions in different parts of the tropics. So one of the most obvious reflections of those transitions is the forest cover in forested landscapes. So during a frontier clearing is where the forest, we would see the forest cover declining, which is the issue of carbon emissions from deforestation right now, to a stable kind of forest cover, and an increasing forest cover such has been observed in this area, or in New England and in Europe and in some parts of the tropics even. So different places are in the tropics are in different stages of this kind of transition, if you want to think about it that way. And the real concern about the carbon emissions aspect is in this stage here. the two big issues, the two big global environmental issues, biodiversity and greenhouse gases. You can think about how they're affected by places moving through this transition. But in tropical countries, we have the situation where different countries are in different stages of this transition, which really sets up some difficult policy challenges, which I hope we can get into later. But when it comes to the carbon emissions issue, we're really addressing those places which are undergoing clearing at this stage in their history. Well, what do we know about carbon emissions from land use change in general, particularly deforestation throughout the last century and a half or so? This is work by Ski Houghton, who has really devoted his career to this one particular issue of carbon emissions from deforestation. And we think we know that about half of all the carbon that has gone into the atmosphere, going back to 1850, comes from land use change. Of course, right now, in the contemporary period, the major emissions that are going into the atmosphere are predominantly from fossil fuels. So the deforestation part is maybe somewhere between 10 and 20%, I think more closer to the 10, but something like that. But in the historical time frame, about half of all the emissions going into the atmosphere have been from land use change. So that's the lighter green here. The emissions from fossil fuel, we know, is the really big issue when it comes to climate change right now. And if you are familiar with the carbon cycle science side of things, we know that there are things we do not understand about the carbon cycle. We do not have it all balanced, that there is more carbon, or we think there's more carbon going into the atmosphere than we can account for in the atmospheric accumulations and what's being accumulated into the ocean. So we don't have this fully figured out, and there are some processes that we don't quite understand that are removing carbon from the atmosphere. And part of that issue may be that we may not have this term completely figured out. I personally think we're overestimating this a bit. But certainly the deforestation land use term is one piece of the whole issue, but as I said, in contemporary time period, not the major piece right now, but nevertheless an important piece. So that fits into the policy discussion, because recognizing that we need a variety of approaches to reduce greenhouse gases in multiple ways, that there's not one magic bullet which is going to address the climate change problem. The deforestation piece is a piece of that, and that has been recognized in the policy discussion first brought to the Conference of Parties, the United Nations Framework Convention on Climate Change, in the 2005 meeting in Montreal, where it was put on the agenda to consider carbon credits for averted deforestation for developing countries for the post-Kyoto commitment period. In the current Kyoto Protocol, there's carbon emissions from deforestation really are not in the suite of mechanisms that exist to reduce emissions. There are project-based mechanisms for sequestering carbon or offsetting from sequestering carbon. But on a national scale, that's not in the Kyoto Protocol right now. So the discussion is currently, how can we set up a policy that provides carbon credits or incentives for developing countries to reduce deforestation, hence reduce emissions that would otherwise go into the atmosphere at a national scale. So moving from a project scale to a national scale. And many people in this room are heavily involved in this discussion on the policy side and have really contributed to moving that forward. But going back to the science side, what do we really know? Well, we know that there are various estimates of carbon emissions from deforestation in the literature, and it's pretty uncertain. Those estimates vary quite a bit, and there are many reasons for that. But you can see that this kind of variation in the 1980s, going all the way up to 2.4 petagram carbon per year from Fernside down to our lower estimate here. and that continues into the 90s, and just now we're starting to get some estimates for the current decade. So you can see a variety of different estimates and a couple of different approaches that have been used to make these estimates. The primary approach is the bookkeeping approach, which Guy Houghton has championed, which is just kind of an accounting approach to track carbon and see where it's going into the atmosphere and coming out of the atmosphere. Did you have a comment?
Yeah, I don't know if this is just an element of sands shifting, but so when I worked on the IPCC report about 5 years ago, when we did the global carbon balance there, and I think it was based on Ski Houghton's work, it actually turned out that the net carbon terrestrial sink was positive, or at least the estimate at that time was positive. Is that something, has it been shifting on both sides of zero for a while, or is there pretty solid evidence right now that deforestation emissions are exceeding the amount being reabsorbed in terrestrial systems?
The question of whether the tropics is a net source or a net
Even though, I mean, globally, really. I mean, I thought, the slide you showed a couple ago, it made it clearly look like, that terrestrial ecosystems are a net source and have been for some period of time. And I guess I was thinking not too long ago, I thought there was evidence that globally that terrestrial ecosystems were net sink. And is that, am I?
Yeah, well, there's we don't have a very good handle on the sink side of regrowth in temperate latitudes, but that is a sink. Mm-hmm. And there's some recent papers that have come out suggesting that the tropics net is a sink, small, but a sink overall. So you take into account the source term from deforestation and the sink term from the physiological mechanisms that the net is an overall sink.
So we're still not, I guess,
we're still not sure.
Kind of uncertain which side of zero we're on.
Yeah.
Okay.
Yeah. Yeah. I'd say that's fair. Yeah. Okay, but we do know that we have a range of estimates, and when you think about the complexity of trying to sort out this whole complicated mosaic on the landscape, it becomes pretty clear why there is this range in estimates. But basically, if we're getting just very simplistically, if we want to estimate the carbon emissions from deforestation, we're considering the initial loss, which is generally process of fire in the tropics, and then respiration from decomposition of the remaining debris over time, and the uptake of carbon that might happen if there's regrowth or regeneration from abandonment or any regrowth for some reason. So the issue really is about how do we estimate all of these terms, and how do we know if we're getting anywhere near correct? And there's a couple of two different basic approaches, and one is this kind of committed flux. So if we deforest today here, and we know that there's going to be respiration into the future, and here maybe some regrowth into the future, what's the committed flux at this point in time? How do we estimate at this point the initial flux plus all of those fluxes that are going to occur into the future? Say it's a 10-year committed flux or a total committed flux into the future. That's one kind of approach. The other approach is a kind of annual balance. So if we consider at any one time how much carbon is going into the atmosphere, we have to take account of the historical legacy. So how much regrowth is occurring from deforestation, previously cleared areas that were subsequently abandoned in that time, or how much respiration is occurring from prior clearing. So we have these kind of two different approaches. Are we estimating what's going into the atmosphere from current time, taking into account the historical legacy, or are we estimating the carbon emissions at the current time, but taking account of the committed flux to some amount of time into the future? So we kind of confuse that when we compare these estimates. Not sure exactly how much difference it makes, but we've been kind of sloppy, I have to say, in making it clear how we're going about doing these emissions. And then if you take account that we really have very poor knowledge of the distribution of biomass on the land surface, all of those uncertainties compound into these emissions. So let's focus now on just the part about the deforestation area. So that's just the first piece, is how much area is being deforested. The second piece is then how much carbon is being emitted from that area. So what tools do we have for monitoring deforestation area? We pretty quickly get to the need for remote sensing, just because there's really no other way to cover the type of the land surface without looking at it from the top. And we really had three basic approaches to do that. And the workhorse has been the Landsat-like sensors, Landsat, Aster, Spot, these type of Landsat-like sensors, which give us the best information in terms of spatial resolution, but we have missing data going back into the past. We don't have complete coverage. We have cloud problems and a whole range of issues why we can't get a very detailed temporal resolution using that type of approach. Since 2000, we've had the MODIS sensor, which gives us a daily observation, which is a huge advance on the Landsat in terms of temporal coverage, but the spatial resolution is coarser. And we know in some parts of the world, the spatial scale of clearing is pretty fine. There's some small clearings, but then again, there are some parts of the world where the clearings are very large, and MODIS is a useful tool there. To go back into a continuous record, going back into the 80s, we're really only left with the AVHR, Advanced Very High Resolution Radiometer, which is extremely coarse resolution. That's the only thing we have going back a couple of decades. And what we did in previous work was try to use a combination of the AVHR with the Landsat approach to cover the entire tropics and make the best estimate we can for what happened in the 80s and 90s. So the estimates that are in the previous IPCC and have been in the literature are basically come from the FAO's national level reporting of changes in forest cover. And some of you may have worked with these kinds of national statistics, and you would know that they're maybe accurate in some places and extremely questionable in other places. But that's really been the only source for the type of bookkeeping approach that Ski Houghton has used. So for the 80s and 90s, we used combination of the AVHR and Landsat to just get the best handle we can on another approach to estimating the emissions. And without going into all the details, what we came up with was a estimate of emissions for the 80s and 90s. You're just looking at the total tropic that is substantially less than what was estimated using the FAO approach. We published this work, and at the same time, which we didn't know about, our European colleagues were doing a very similar type analysis, but using a sampled Landsat approach. So we did an AVHR approach covering the total landscape, wall-to-wall landscape, and the Europeans did a Landsat approach, but with a sample, and they came up with a very similar kind of conclusion for the 90s. So we have these two satellite-based estimates for the 90s, which are about half, substantially less than what has been estimated using the FAO deforestation areas, which is kind of a funny thing to say, that we've been overestimating the emissions from deforestation. But I think we're not certain. But I think that this is consistent with some of the atmospheric measurements, and we need to see how we can get some more robust understanding around this. But I think that we've been overestimating the amount of carbon emissions from deforestation. Again, how does that feed into the policy discussion? It doesn't really change the policy discussion too much, but it does indicate that the wedge that we get out of reducing carbon emissions from deforestation may be less than what we've been thinking with the higher estimates. So that's for the 80s and 90s. What about the current decade? And so now I want to talk about the work that we've been doing to really try to reduce these uncertainties and get a better handle on how we make these carbon emissions. But when we move into this decade, we have to think about how we're estimating carbon emissions, taking into account that the dynamics of deforestation are really changing. Just looking at just an orientation here for the Amazon. This is the BR-163, the road that's being paved, and the port here at Santarém, which is being used to export goods out to Europe, and the road that's being paved to go through Peru and export out to China. So there are huge dynamics which are going on, centered around the push for the Brazilians to increase their exports, which is certainly important for the economy, and improve the infrastructure. But we see that reflected in the spatial pattern of deforestation. So in the earlier decades, really the poster child for deforestation is this area in Rondônia here. So when I was in graduate school, this was like what we all thought about was deforestation, was this fishbone type of pattern, which is planned clearing along the border to secure the border. And these dots here are all fires, so fires are associated with the clearing. So this fishbone pattern, these fishbones really are roads, these roads here. So this is the spatial pattern that we thought about in terms of Brazilian deforestation. And that dynamic has really changed moving eastward, where the really hottest hotspot of deforestation right now is in this area of Mato Grosso. You can see there's one lobe of forest coming down. This is an indigenous reserve, the Xingu. And we see a very different spatial pattern. We see these big clearings. You can see the fires associated with that. And these big clearings really are huge clearings. And you would think you were in Kansas or somewhere in the Midwest. I mean, really intensive mechanized type clearing. So this dynamic in this part of the world is really changed very rapidly over this last decade. Now, not to say that this is representative of the entire world, but certainly here.
Soy cultivation and...
that's what I want to get to next. So what is it? Yeah, exactly. Okay, so what is it? There have been, well, we know that Brazil has really increased their export of soybeans. This is just showing the export to China in this decade. And there have been claims that this increase in soybean exports can be achieved, or has been achieved, without any new deforestation. So the argument there goes that the areas which have been converted for soybean cultivation were previously cleared for pasture. So these places, that side of the debate says that places were converted to pasture and then a secondary conversion to cropland. So there's no new deforestation. That's one side of the debate. The other side is that this increase in soy production has led to this massive new deforestation. That's a sort of Greenpeace view of the world. And this debate has gone on for a couple of years without having a lot of evidence behind it. And what we decided then to do was to see if we could use our MODIS tools to try to put some evidence behind this debate and be able to answer exactly the question that you just asked, what's behind it. So the way we tried to do this, or the way we did this, was to look at the phenological signal using MODIS data. Now, MODIS data, again, is daily, so we can get a phenological signal. You wouldn't be able to do this with Landsat data. And look at those areas which have been deforested, those polygons of deforestation that we know about from the Landsat analysis, and look at it after it's been deforested and be able to determine whether it was subsequently used for mechanized cropland, primarily soy, or whether it's been cleared for pasture. So try to put some numbers behind these two extremes of no deforestation from the soy expansion or all deforestation being driven by the soy expansion. So the way this works is that a forested signal is, this is a vegetation index, would stay green all through the year. And a signature of mechanized cropland, soy, you see it very clearly. This is after some getting rid of a lot of noise and junk in the MODIS time series. But you can see very clearly it gets very, very green during the peak of the growing season, and then you can see the second crop here and going through year 2 and year 3 and starting year 4 here. There's a very, very distinct signature for that mechanized cropping. If it hadn't been for that distinct signature, we wouldn't be able to do this. A pasture type signature looks something like this. You can see some phenology, but nothing like this green, very, very green period during the height of the growing season. So using this phenological signature, we then went back for this particular area. So we're in the state of Mato Grosso here. So we did this over all of Mato Grosso, and again, this is really one of the hottest hotspots of deforestation. So again, the conclusions don't hold up for the rest of the world, but this is certainly a really important area. And we could ascribe then the post-clearing land use to every deforested parcel. So the red places here, we see within this 5-year window that it was subsequently used for cropland, supporting the soy leading to deforestation argument. And the yellow is deforestation that has subsequently become pasture. So what we found then was, as usual, the answer is somewhere in between. That not all, that this is the whole slug of deforestation in Mato Grosso from 2001 to 2005. So most of it is actually going to pasture. So the pasture clearing is the dominant use following deforestation in this area. But there is a pretty hefty slug which is going directly to mechanized cropland immediately following deforestation. So neither extreme of that argument really holds up. The predominant use is pasture, but there is a significant amount of deforestation which does which is being driven by the soy expansion. So that peaked in 2003. That amount, this is this blue amount here of the total deforestation. This is the amount that's going for mechanized cropland. You see, it's about 20-something%, and it peaked in 2003 when the soy prices were at their highest, which makes sense. So then the soy price fell, and it's going up again. So we'll see what happens. There's in the interim, there's policies to reduce deforestation. There's variability in climate. There's all kinds of factors that go into determining what drives deforestation. And I'll let Spaffler here, he'd have a lot to say about that. But this is what we see for this time period, that the amount of clearing that's going directly for cropland follows pretty closely the price of soy. What we also see is those places which are associated with cropland conversion are big, so really big. So the clearings which are greater than 500 hectares, which is a huge, huge clearing, there's a greater proportion of the areas that are going for cropland that are really, really big than for pasture, although there is a good number of very large pasture clearings also. But generally, the mechanized clearing is really associated with these very large clearings, as would make sense. So what does that mean for carbon emissions? So there's a pretty strong implication for carbon emissions in that those areas which are being converted directly to cropland, this is what it looks like. The biomass is pretty much completely removed, and there's no biomass remaining because to be able to use machinery and so forth. So the removal of biomass is near 100% on those areas. Whereas those areas which are cleared for pasture, there's a good amount of biomass remaining in those areas. So when we estimate the carbon emissions from deforestation, it's not just about the area that's cleared, but how much of the biomass is removed. So we really, if we're going to be accurate in a situation like this, we have to make that distinction between the post-clearing land uses so that we can remove the appropriate amount of biomass. It's very striking on the landscape that these areas are just completely cleared up. There's another dynamic that we don't really take account of in our carbon accounting the way we're doing it, and that is that secondary type conversion, pasture to crop. You can see here some machinery behind here, so there's cropland behind here, and there's a fence, which is a pretty good indication that this was pasture before. So there's quite a few places on the landscape where that secondary transition is going on, and that involves a removal of this amount of biomass to this. So there's another pathway through which carbon is going into the atmosphere that doesn't really get accounted for in our, if we're just looking for the deforestation. So getting back to this distinction, we also see another piece of evidence that the combustion completeness or amount of biomass that's removed really is different between these post-clearing land uses is in terms of the fire frequency. So we have the MODIS active fire data, and we see that those areas which are going for cropland, we see a larger number of days where we see fires, which would make sense with this higher removal of biomass than we see for those areas that are going into pastures. That's another piece of evidence that we need to take account of the amount of biomass that's being removed. So what we've tried to do, and working with Prasad and Jim Randerson and others, is to just look in this particular area at a pretty high resolution and try to model these processes and take account of the post-clearing land use and different combustion completeness and see what we need to understand about these processes to be able to scale up to the whole tropics. So what we're doing is looking at the deforestation process as a fire emissions problem, which it really is, because deforestation is fire, although not all fire is deforestation. There's quite a bit of fire associated with pasture maintenance. But to try to model the emissions not in this kind of bookkeeping way, but use the tools that have been developed for fire emission modeling, carbon emissions from fire, and apply it to the deforestation problem. So knowing what the land use is following deforestation, which we know from the phenology, and knowing what the active fires are, and knowing where the deforestation is with Landsat, and more information about the burn scars which occur in the pastures which have already been cleared. Put this into a modeling framework using a CASA type approach. So we've modified this model, we call it DCAF, to be able to estimate the carbon emissions from deforestation using this approach. So what I wanted to do was go through a couple of observations that we're learning from this modeling activity, and then see what it means for scaling up to the whole tropics. So the first thing that we see, and again, this is just in the state of Mato Grosso, so we're running this model at a 250-meter resolution compared with global models, which are generally at 1 degree. The first thing we see is that there are lots and lots of fires. If you look at the active fire data, there are just thousands and thousands of fires. Many of those are for pasture maintenance, for clearing pasture and every couple of years, just burning the pasture to clear it out for the cattle. And those types of burn scars associated with those types of fires cover up to 60% of the landscape. But in terms of the emissions, they really don't account for much, maybe 20%, because clearly there's less biomass there. So not all fires are equal is our first lesson here. And if we're going to model carbon emissions from deforestation using fire as a tool, we have to make the distinction between the maintenance fires and those fires for clearing. Secondly, in this area, there are many tens of thousands of small deforestation events. Small meaning less than 25 hectares. So in some parts of the world, a 25-hectare clearing would be big. In this part of the world, a 25-hectare clearing is small and generally associated with small-scale landholder and generally associated with a pasture use, not a mechanized type clearing. So most of the deforestation in terms of the number of polygons and deforestation events are small. when you look at it in terms of area, those small clearings don't amount to much of the area. So that's the blue in here. So up to 80% or between 70 or 80% of the deforestation polygons themselves are small clearings, but in terms of the deforestation area, it's less than 20% of the total area. So that says to me, why, let's go for the big clearings first. That's the big, the low-hanging fruit, you could say, in terms of reducing emissions, because it's hard work to find all of these very small clearings everywhere. So if they don't amount to much in terms of the overall emissions, let's concentrate on the big emissions. That's what this says to me. And also, we're learning that the emissions, the carbon emissions from deforestation, occur over multiple years because the fires keep going. So the debris is cleared, piled up, dried, burned, piled up again, burned again, and that goes on. That can go on for several years. So this is just one particular deforestation polygon, and these dots are fires. So you can see that this happened in 2002, but the fires themselves continue for multiple years. So if we want to get the emissions right on an interannual time scale, we need to take account of these emissions which are continuing into multiple years after the initial deforestation. So the way that if you just take the deforestation area as it occurs in the first year, and then all the emissions are for that year, we won't get the interannual variability right. And what we see from this is that we have this carryover in emissions. So we're seeing emissions from deforestation that started several years ago. So again, in terms of policy, I think we have to really be careful about saying we can do annual emissions accurately, because if we are to do that, we really have to take account of this multi-year clearing process that goes on. And the fourth point here is that the emissions depend on the post-clearing land use, not just the area. So again, that combustion completeness, when there's complete removal of biomass, as there is for the cropland type conversions, we see more emissions per area than for the pasture type emissions. So how much difference that makes? Maybe that balances out in the end, depending on the scale that you're looking at, but that's something that we need to take account if we're trying to reduce the uncertainty. And also this secondary conversion, this secondary transition from pasture to cropland, going around that second loop, so initial clearing for pasture and then additional clearing of removal of biomass for cropland, is also a source of emissions which hasn't been accounted for at all. So whether that's important or not, I'm not sure in the global scheme of things, but certainly in this area, there's some proportion of the carbon emissions are coming from those secondary transitions that we haven't accounted for in our normal way of doing the bookkeeping approach. So we're learning these things about what really matters and trying to think about how we scale it up to a pan-tropical approach, because we can't know lots and lots of detail in every single place. So we're just trying to pull out what are the key lessons from studying this area in detail. So one of the ways to see whether we're at all getting in the right ballpark is to compare the estimate of carbon emissions from, again, just this study area in Mato Grosso, and compare that with the sort of Ski-Houghton bookkeeping approach. And this is preliminary, and Ski's in the process of running it with his own, make sure I didn't make a mistake here. But to be able to use that approach where there is not a distinction for the post-clearing land use. And what we see if we aggregate over the average 5-year committed flux now going into the future, so we're looking at the initial deforestation emissions from the fires, and then what's the respiration that goes 5 years into the future from that, and do our modeling decap approach with that, and do the Ski-Houghton bookkeeping approach. We're not that different, really, but that's because we balance out here. The decaf approach is higher on the forest to cropland conversion, so this is decaf and the bookkeeping approach, and substantially lower on the forest to pasture type conversions. And the respiration then is the flip side of that, because the more you burn in the beginning, the less you have left to respire. So in terms of aggregating over the 5 years and the full spatial extent, that kind of balances out. But depending on what proportion you have of these different land use transition types would determine whether it really makes a difference or not. But in terms of the overall number, it's very similar. And another comparison, and this is where we're working with Prasad and others on the global fire emissions database, is to take a cookie cutter of this global fire emissions data set, which is at a 1 degree resolution, and see how we do in comparison with our decaf, our more detailed decaf modeling. And this comparison doesn't look particularly attractive on a grid cell by grid cell level, and certainly at an interannual level. But when we aggregate over the 5 years and over the full spatial extent, we get pretty similar numbers. So perhaps we're agreeing for the wrong reasons, but you can see here, some years we're low, some years the other is high, so it all averages out. So, but what we're trying to do is see if we have some robustness around the sort of ballpark number, and comparisons with these two different data sets. We're just kind of oscillating around the same general number, which in one sense is reassuring that we're not getting wildly divergent estimates. So from this, what a modeler would consider a high-resolution analysis, what a remote sensor working at a Landsat scale would consider a extremely coarse resolution, a 250-meter resolution, what are we really learning? I think we're learning that the clearing for mechanized production, which is the big new dynamic, requires that we develop new methods to take account of the amount of biomass that gets removed and be able to fold that post-clearing land use into our estimate of carbon fluxes. As I said, maybe we're agreeing for the wrong reasons, but these multiple methods are sort of coming around similar estimates when we aggregate over this 5-year window and over the full spatial extent, so we're not wildly off the charts. That if we're going to get the interannual variability right, and I don't think policy should be based on interannual estimates of deforestation because it varies so much, but if we are to try to get that right, and that's really important from a science point of view to compare with the CO2 growth rate, that we need to take account of the whole dynamics of deforestation, that it really occurs over multiple years. And that the scaling up really does remain a big challenge for us. And what are the tools that we have to be able to scale up to the whole tropics, to be able to use a kind of fire emissions modeling approach? And we have multiple different kinds of data sets, and they all have their issues and problems. So what we're struggling with here is how do we combine what we know about deforestation hotspots from a MODIS global analysis. Really, we know, I think we have a pretty good sense of where all these hotspots are. How does that compare with the global fire emissions database? You can see in some sense you have a pretty good spatial agreement between where the emissions are coming from and where the deforestation hotspots are. We have aerosol optical depth information. We have the MOPIS CO, which is where Prasad comes in. And what we're really kind of struggling with is how do we put all this together and all of these data sets, being imperfect as they are, to give us a improved estimate of carbon emissions across the whole tropics in a way that can be repeated through time. So that's the issue, and they're working with, and it raises several different issues, which I think are really out there to be answered, and that is which land use transition types are really contributing the major source of emissions. So if you look at the Brazilian Amazon, the legal Brazilian Amazon, in terms of the contribution to deforestation area from different size clearings. So you can think of size of clearing as a kind of proxy for degree of mechanization. these large clearings greater than 100 hectares. This is in a single year. You can't do that unless you have tractors and chains and things to be able to achieve that type of clearing area. Again, if you look over the whole Brazilian Amazon, those large clearings are 5% of the total number of clearings, but about half of the deforestation area. So again, that's kind of the low-hanging fruit. These small clearings, there are lots and lots and lots of them, but they don't contribute, only contribute about 20% in terms of the overall cleared area. So that gives us a clue about who the actors are, that these are really the small landholders, and this is the mechanized large landholders. So if we're going to think about what policies might be effective, we have to think about who the different land use actors are, where we could get the biggest bang for the buck, if you want to think about it like that. Another question is whether this soy expansion, although it may not be directly leading to deforestation, is a push factor, so pushing the cattle ranching, pushing the pasture further into the frontier. And you can certainly see this with the agricultural census data. This is cattle, the pasture, and this is the soy. So you can see from 90 to 2005 how that frontier has moved in, and the soy has followed along. So is it the case that this increase in soy production here is displacing the pasture, and how might that dynamic develop into the future? And again, the biofuel issue is coming up as being really important in terms of whether the expansion of sugarcane for biofuel production in the south here will have a push effect for the pasture and the soy further into the Amazon, even though the sugarcane might not be directly grown here. So that's a huge issue that's out there. Another issue is whether what's the dynamic between drought and clearing. In years where there is drought, is that leading to more clearing because it's easier to clear? Is it leading to more escaped fire and subsequent use of that land because it's already been subject to fire? And this is a dynamic, that type of human behavior, drought, feedback has not really been folded into our global models. We've made big advances in the interactive vegetation, but putting the people in there and how the human land use responds to drought is I think really, really important. And we can see how that's playing out in 2007, this year, where it's dry in the eastern part of the Amazon. We're seeing lots and lots of fire, really high fire year. So we've seen a reduction in deforestation area and fire here, 2005, 2006, and this year the fires are way, way up. So we don't know yet whether that's escaped fires, whether that's new clearings, because it's easier to clear, whether that's a function of something else, not climate at all. But understanding that whole feedback between drought, human land use, which is a positive feedback to climate change, what that dynamic is like and how we fold that into our understanding of the future. So from the science side, we have a whole bunch of questions to answer. From the policy side, it's the usual issue that we have as scientists. We know about all of these uncertainties and inaccuracies and how we could always make our estimates better. But from a policy side, do we know enough to say something useful for the policy discussions? So I know we all struggle with that as scientists, but I think in this case we know enough where we can be useful for the policy discussion, and we do have methods and approaches to be able to monitor deforestation and estimate carbon emissions. So what does a policymaker see? Well, if a policymaker looks at the IPCC, they see that for this is the carbon emissions for the 90s, they see a rather large range in the estimates for the pantropics for the 1990s, going from a low end estimate here of 0.5 to a high of 2.8. That's a rather large range, but what the IPCC does, as they do, is take the average of the published estimates, so there we get the famous 1.6 gigatons per year number. So from a policy perspective, is this range good enough to base policy decisions on? Well, we still know it's a somewhere around this number. Again, a decreasingly small number of the fossil fuel emissions. So what we've been doing is working to provide information just on the technical side about how carbon emissions from deforestation could be estimated in a practical and reasonable way for the implementation of policies to reduce carbon emissions from deforestation. So working through an international group for the Global Terrestrial Observing System, which is way under the UN hierarchy somehow, just trying to really provide straightforward information about how deforestation areas can be monitored and how we can estimate these carbon emissions in a way that is useful for the policy discussion. So clearly, it's not useful to say we should do detailed modeling everywhere where we have to have all of these inputs and we have all of these uncertainties. That's really not a very useful policy discussion. But can we put forward approaches that are practical for countries to implement? And again, we're talking about a national scale, so not estimating carbon emissions at a project level, but at a national level. That's what this policy discussion is all about. So we tried to put together some, you might say, sort of practical, almost how-to kind of ways about how carbon emissions could be estimated from within countries. So we're really talking about developing the capability within countries to do this estimate. I don't think there's any thinking that having some kind of global superstructure to estimate the emissions and provide that information to a country and expect them to believe it. That isn't going to work. So we're really talking about developing national capabilities to be able to estimate the carbon emissions. So some of the points that we're trying to get across in this effort to communicate the technical capabilities to the policy arena is that there are various methods to measure change in forest cover, and whether depending on the national circumstance and scientific capacity and how much money is available to buy data and so forth, ranging from just purely visual interpretation to complex automated algorithms, and that there are a variety of methods, and that what's less important than using the same method everywhere is that the methods be transparent, verifiable, and repeatable. And there are several national examples that do exist of countries which do monitor their forest cover on an annual basis. And really the issue is not so much the know-how for doing that, but developing the national capacity and the very important issue of getting data available at a reasonable cost, which to me is really the biggest constraint for that. Another conclusion that we're trying to get through is that the forest degradation issue, the kind of selective logging, it's important. It's out there on the table. It's a lot more challenging to monitor and even more challenging to estimate the carbon emissions from that type of forest disturbance as opposed to the out-and-out deforestation. And that estimating the area of change is really the first piece. But what we really need to know is the flux, the carbon flux. So the IPCC has been through a lot of work to develop these guidelines for estimating carbon fluxes from at the project level. So it's quite appropriate, in the opinion of this group, to use those same approaches applied to the national level. So instead of promoting detailed modeling, to promote using those guidelines which countries have already agreed upon. So that seems to be a way to go forward with this policy discussion. And again, there are several examples of countries which have forest monitoring systems in place. Brazil is the primary example where they have their annual deforestation, and it's transparent. You can go on the website and pull down those data. It's really quite an achievement. Not perfect, but it's pretty impressive that they do that. India is another example where there is countrywide deforestation or forest cover monitoring every 2 years. So I was lucky enough to visit where they actually do that analysis, and again, it's pretty impressive, and they do a lot of field work and validation for that. There are other examples, like Bolivia has picked up the approach to monitor large clearings using MODIS data. So that, again, you can go on the website, it's transparent. So this transparency is, I think, opens up a whole realm of discussion for policy that was not with us when the Kyoto Protocol was being discussed, and the issue of carbon credits for deforestation was taken off the table because of these, well, one reason was because of these methodological challenges. And I think we can safely say that we're somewhat beyond that now, that from a technical point of view, I think we can see ways forward where a national approaches to estimate carbon emissions could be put into place. Not that it's easy, but it could be put into place. And that leaves us with getting past the technical issues and a whole range of really thorny, sticky policy issues, which we were talking about at lunch today, that once we have the technical capability, then, okay, well, should we include forest degradation? What really is the baseline reference period? These now are outside of the technical realm and into the policy realm, and there are countries throughout the tropics who are in very, very different stages of these forest transitions. And so, for example, Costa Rica or China would really be wanting to get carbon credits for increasing forest cover, which is really not in the discussion right now. A country that is in this part of the curve, historical high deforestation rates are an advantage there in terms of reducing from those high deforestation rates. So there are different countries in really, really different circumstances, and that came out at lunch today, and it really plays into how do we get onto all of these policy issues once we have the technical issues kind of sorted out. Market mechanism or fund, that'll be a big issue in Bali. Permanence, how do we ensure that these areas aren't cleared 10 years later and then all the carbon goes up into the atmosphere. International leakage, promoting co-benefits with biodiversity and poverty alleviation, making sure there are no perverse incentives that would be a disadvantage to those other important objectives. So there's really, really sticky policy issues ahead, and what we've been working on is really staying on the technical side and providing the best input that we can about the technical capabilities to estimate carbon emissions. So to wrap up here, we have big changing dynamics in the tropics, particularly in the Amazon and in Southeast Asia, towards mechanized, large clearings, which really changes the way we think about the actors and about how we even estimate the carbon emissions. That there are a bunch of open science questions which are exciting to think about, and we need to get on to resolving that in terms of the feedbacks with the human land use, how these different drivers play out, how we scale up to pantropics. So we have a science agenda here, and we have a policy challenges for this policy discussion, but we think that the technical challenges can be overcome, and really the realm is in moving forward on these policy challenges. So with that, I thank you and open it up for some questions.